everyone. I'm going to be going over how to balance a reaction in acidic conditions and also how to identify oxidizing and reducing agents. So this is our given equation, ClO3 minus plus I minus, and it goes to iodine, 2 iodine plus chlorine minus, with a minus charge. So this is the equation that needs to be balanced in acidic conditions. But first and foremost, I'm going to do the first thing to get this out of the way on identifying the oxidizing and reducing agents of the equation. If you're not familiar with oxidation numbers, it's not too bad. From the oxidation numbers, you can figure out what's being oxidized, what's being reduced, and you can figure out the oxidizing agent and the reducing agent. So let's start on this side. So for oxidation numbers, oxygen is almost always -2. So this is -2. Now, -2 times 3 is -6, and you're trying to figure out the charge for chlorine. Well, keep in mind that this compound needs to have a -1 charge overall, as you can see here. So let's call chlorine X. So you're trying to find that charge plus -6, which should equal a -1 charge overall. So in order for this to equal each other, X has to be 5. So chlorine here is +5, has a +5 charge. And then iodine here is a negative charge, so oxidation number is just -1. For iodine here, I2, this is in its standard state. Anytime an element is in its standard state, so like H2 gas, or for example, Br2, like bromine 2, the oxidation number will always be 0. And then chlorine here has a -1 charge, so the oxidation number is -1. Alright, so you look at the elements that are the same and try to see what has changed in the equation. So iodine went from -1 to 0. That means that it's more positive as it goes from reactants to products. Since it's more positive, that means it lost an electron. So this means that iodine is being oxidized. So this is being oxidized. And then as for chlorine, chlorine is the one that changed values as far as going from +5 to -1. So it's more negative. Since this has happened in the reaction, that means that chlorine has gained electrons. So since it gained electrons, that means that it's been reduced. So let me change colors here. So in order to identify the oxidizing agent and the reducing agent, the oxidizing agent, remember, for oxidizing agent, the OA, as I usually call it, this is what's being reduced. And then for the reducing agent, it's the opposite. So it's being whatever is being oxidized. Okay. So for the oxidizing agent, so you look at your reduced, part of the equation, and um, you're between ClO3 minus and Cl minus. We'll see, for the oxidizing agent, it's what's being reduced. It's not what's in the reduced form. Cl minus here is in the reduced form. That's not what you want. The oxidizing agent is what's being reduced. So just watch that wording if it's ever asked on a test or something. So the oxidizing agent is ClO3 minus, and then the reducing agent is your I minus. So as you can see here, this is what's being oxidized. I minus. Okay, so you've identified your oxidizing and reducing agents. Next, this is an outline. It's like a brief outline I made on how to balance in acidic conditions, how to balance a reaction in acidic conditions. So first and foremost, you actually, before you do any of these steps, you have to split up your overall reaction. So you have to split up this reaction into two parts. So you have to split it, you have to have an oxidation reaction and a reduction reaction. And then you can do all of these following steps in order. So for each of the following steps, you have to do it for both the oxidizing reaction and the reducing reaction. So first step, you have to balance all the elements except oxygen and hydrogen. Second step, the only way you can balance oxygen is by adding H2O. And then the following step, third step, is to balance hydrogen by adding H+. After you do that, the fourth step, balance charges by adding E minus. These are your electrons. So add electrons in order to balance the charge. And then for the fifth step, add the oxidation and the reduction reaction together once they are balanced. Once they're balanced, you can finally obtain the overall balanced reaction in acidic conditions. So I don't want to run out of time, so I'm going to have to cut this short and make a second part to this video.